So, Helio College math students, let's do some trigonometry. Here we have a right angle triangle with the sides labelled. There's our angle in question. So of course this is on the opposite side of the triangle to that. So that's the opposite side. We have the longest side, the hypotenuse, and we have the adjacent side running alongside the angle that's marked. Now, you may be familiar with these three trigonometric ratios: sine, cosine and tangent. So we use these in order to find the unknown side lengths of right angle triangles. Right, so a little word I want to clue you guys into here. And the word is Sohcahtoa, and it's spelt like this. And I used to use this word, and I still do sometimes, to remember my trigonometric ratios. So where does this come from? Well, the sine of the angle is equal to the opposite side over the hypotenuse side, SOH. So, the cosine is equal to the adjacent over the hypotenuse, CAH, Ka. And the tangent is equal to the opposite over the adjacent, TOA, Toa. So I'll show you how to use Sohcahtoa in an example. Here's a worked example that you could follow, but I'm going to go straight on to these ones here in V3.3. And let's try this one over this side. So the first step here is to use your understanding to label the sides which are involved. So I mean, here's your angle. The sides that are involved are our side here x and our side here which is 4.2. Of course we want to find x. The two sides that either have an x or a number on them are the two sides that are involved, but what sides of the triangle are they? Okay, so here we have this side length here running alongside the angle. That's the adjacent side. I'm going to mark it with an A. And here, this must be our opposite side. It's on the opposite side to the angle. The side that's not involved here is the hypotenuse. We don't care about that at all. Okay, so let's refer back to that word, Sohcahtoa. Well, why is this useful? Well, I know that I want to find the opposite side here, and I've got the adjacent side. So those are the two sides that are involved. There they are together there, O and A. That means I need to use T for tangent. Okay, now, what we write down is our trigonometric ratio. We've identified that because O and A are involved, it's T for tangent. And we say tangent of the angle, 48 degrees, is equal to, now if we look back here, we see that for tangent, it's the opposite side divided by the adjacent side. So our opposite side is x, divided by the adjacent side, 4.2. Now this process is a little bit involved. We'll go through a couple more examples in this video, but that's what we need to write down initially. Then, of course, we want x on its own, so that 4.2 needs to go over the other side. On this side it's dividing, so on this side it will times. And it goes away. So x is equal to 4.2 times the tangent of 48 degrees. Now this here goes straight into the calculator. Have a go at typing that in and see if you can get this answer. The answer is 4.66 and so forth. So we could say 4.7 centimetres. Now, let's go through another one here, just to make sure we've got it. I've used a lot of this space up here, but I'll just do this one down in this region here. Okay, very quickly, identify the sides that are involved. Maybe pause the video and give that a go first. Okay, so we want x, which is the adjacent side, and we're given the hypotenuse side. So this time A and H are involved. A and H, where do they appear together? Here, next to the C for cosine. So rather than being tangent, this one requires us to use cosine. So we write cosine of the angle, 37 degrees, is equal to, okay, so we can use Sohcahtoa to decide which number goes on, or which of the x and 14 goes on top and the bottom. We looked back before and saw that opposite, for tangent, opposite goes on top of adjacent. O comes before A, so O goes on top. Same for cosine. A comes before H, so the adjacent side goes on top. The adjacent side is what we're trying to find, x, divide by 14. Just like before, the 14 is dividing on this side, so we take it over and it multiplies. So x equals 14 times cosine 37 degrees. So try putting that into the calculator and you should get 11.2 metres. So in the next video, I'm going to show you how to do these ones over this side. They are very similar, but the last step is a little bit different. First though, look at the questions for this video in the description and try those, following these steps. And this is a useful page, even though we didn't spend much time on it. We followed these steps in that working out. We identified which sides were involved. We found whether we use sine, cos or tan. And in our examples, the first one we used tan, the second one we used cosine. We wrote the equation down and then we solved it. So we actually followed these steps in this working out for these two. We went through all that.